Kristine, thank you very much. And so thank you. Just an amazing amount of information that could be gotten. So we have a couple questions to start out with in the Q&A and also in the chat. So I'll start this process. One of our first questions, if you could stop sharing screen, that would be good.
Okay, will do.
Very good. Okay, so here's our first. I think some people were amazed at you being able to drill into corals and take cores. So the question is, how much training goes into being able to drill corals, and do you have to be certified?
Certified scuba diver, yes. So you do need to be certified. We actually do scientific diver training. So science diving is different from recreational diving, where you're just floating around looking at fish. We're actually working underwater. We're carrying heavy pipes and carry these heavy cores underwater. So you use your air a lot faster than you normally would.
Okay.
So there's a bit of training that goes into doing scuba diving and taking cores underwater. So
but you don't need to be certified to actually drill into the coral.
We have to get permits.
Okay, that would make sense, right?
Yes. Yeah. So particularly like flower gardens, dry tortugas, they're both federal reefs. So we have to get permission to core.
So this other question was in reference to your barium work and the drilling mud. And this is, how do corals react to oil spills and not just the production of oil, right?
Right. So that's a good question. We were fortunate that the Deepwater Horizon event, that oil spill did not make it to flower gardens.
Okay.
And flower gardens in general is not heavily impacted by that oil spill. So that's a fortunate thing. So just like any organism that's out in the ocean, and if they're directly impacted by oil, it would become an issue. So yeah, yes, they would be impacted, but for flower gardens, we were fortunate it was not. Okay. So but there's other things that do happen to them. Like when hurricanes come through, the corals can actually roll over, and there's physical damage that happens from the waves during hurricanes. We had in 2017, there was a lot of flooding that happened, plus Hurricane Harvey. And so there was this freshwater lens that was off the coast of Texas that started a bacterial kind of bloom. And that bacterial bloom, it's thought, made its way out to flower gardens because we did have a very strange disease that hit flower gardens that year. And the biologists working on the reef have been trying to figure out what that is. And they're thinking that it's coming from the floods that happened on the coast of Texas started this bacterial bloom that did make its way out to the
flower garden.
Right.
Okay, very interesting. Okay, so I'm going to read you a couple questions from the Q&A. Are you able to determine anything about how marine life interacts or interacted with coral by looking at the cores? Okay,
so marine life, so looking at the cores, some of the big corals that we work on, these are Boulder corals, they're huge. They're, the ones in the Gulf of Mexico, particularly at a flower garden, some of them are 8 foot tall, 7 foot tall. In the Pacific Ocean, they can be 20 foot tall.
Oh, okay.
Some of the largest are 30 foot tall. So these are huge corals. The coral I did my dissertation work on was almost 20 feet tall. And they are home to lots of fish. And sometimes they get little worms that grow in them. And these are those really pretty sea fans. They do have infestations that happen to them, particularly if they get diseases. A lot of the big corals, they get eroded from the bottom by sea urchins and other critters. So you get things that hide underneath them. So when we're out diving, like in the Florida Keys, if you want to find a nurse shark, go peek your head underneath a coral head, because there's probably a nurse shark sleeping down there. Also a really good place to find lobsters. So yeah, but the corals themselves are home to lots of different marine life. So yeah, so they're really fun to go out there and see what's underneath the corals and around the corals. And then sometimes in our coral cores, we can see these worm infestations that get into the coral. And what's interesting is they'll actually grow over it. And because they're slow growers, but they will eventually encapsulate that worm and grow over it and cut it off from the surface. So yeah, really cool stuff happens.
Okay. So in terms of the patterning in the Gulf and and in the Caribbean, are corals migrating in different ways now than they have been 50 to 100 years ago? Because they produce polyps that move around, right? So are we seeing distribution patterns that are different due to warming or cooling?
We are seeing corals shifting northward. So like flower gardens in the Gulf of Mexico is one of the furthest north reefs in the Gulf. If you go across Florida into the Atlantic Ocean, so typically you don't find corals further north than West Palm Beach.
Okay.
But they are starting to find them further north, like up by Cape Canaveral and even up to Jacksonville. And there's been reports that off the South Carolina coast in deeper water, they are finding corals becoming established there.
Interesting.
And in the Atlantic, our furthest north coral reef is Bermuda.
Right.
So Bermuda is the same latitude as North Carolina.
I know.
And there's beautiful reefs in Bermuda. And that's because the Gulf Stream goes that way.
Sure. So part of the issue with climate change and changing of currents in the ocean in terms of cool or warm water is going to be the distribution of corals globally.
Right. And corals like these big Boulder corals that I was showing you, I mean, these corals are, 300 years old, 400 years old, 500 years old. But when they first start, they're little itty bitty guys.
Sure.
And it takes time for them to grow and to establish that reef. So, for a healthy reef to get established, it needs 500 to 1,000 years. Well, and they just don't have that kind of time.
Now, when and that's what I was thinking, because we know about plants having to move northward to deal with changing precipitation and temperature, and and other animals, I would suspect that corals really are about like on a mountaintop. Where do you go?
Right.
If things become too warm.
Right. Well, and then they need to have, clear water. It needs to be warm water. Plus, they need a hard bottom to attach to. So like a sandy bottom's not going to work. They need a hard substrate. So they're only going to occur in certain places. So like going out to flower garden, there's another place called Stetson Bank. Okay. That's the same water depth as flower gardens. There's a lot of fish life there, but it's a muddy bottom. Don't find corals there.
Don't find corals. Well, that actually raises an interesting question that Sheldon Wright asked in the Q&A. What is your opinion then on building artificial coral reefs, and what are the most important differences? Are coral reefs still healthy enough to not need artificial reefs yet?
Right. I think actually a lot of folks I went to grad school with work on artificial reefs. I think it's a good idea to give corals a place to grow and to help them become established. The other big thing artificial reefs have been used for, particularly in the Keys, is when cruise ships do damage to the reef or other boats. So like a ship comes through and just rip up a reef. So what happens is the companies get fined and they go out and start putting artificial reefs to try to grow that reef back. So again, that's not because of climate change, that's because of human impacts. Artificial reefs are really important to get those reefs back and established again.
Right, because we have a group here at Texas Tech, actually out of Waco, that works on a group with a group out of Honduras to build artificial reefs there.
Right. Yep.
Yep. So there's a question about bleaching. Does coral bleaching impact how you research corals, and does it make research more difficult?
So coral bleaching it's happening more and more often. And again, like I mentioned, we have to get permits to go out and core corals. I try not to take more than what I need. If I am collecting live coral, and actually in Little Cayman, everything we collected was dead coral.
Okay.
A lot of it was recently dead. Or I wait. Some of the coral colonies actually are getting different types of diseases. So half the colony will be alive, the other half is dead. So I core through the dead part. The dry Tortugas coral, that was part of it was dead coral, same coral head, but the top of it was dead. The side of it was still alive. So we did a core through the dead part to get the longest record, and then through the live part to get the top section. So I try not to core live coral if I don't have to. And there's lots of corals sitting in archives that people collected back in the 80s and 90s, and we work on those. So I don't collect live unless I have to.
Yeah, right.
Right. But yeah, bleaching is a concern. And if the corals are stressed and they're diseased, we try to avoid them.
Yeah. Okay. So that raises, there's an interesting question too about this. What is the impact and this is one of mine, and this has to do with Texas and in the Gulf particularly, we're seeing more and more dust events from the Sahara come across to the Gulf and to West Texas and drop dust here, which, and so how is that impacting corals and the development of that? And what's the historical record for that? Right.
That's something that Gil worked on with the Haiti corals. So those were micro atolls that were growing right at the surface. So one of the things he did was kind of a proof of concept that we could look at rare earth elements that's coming from Saharan dust, because Saharan dust has a particular fingerprint of those rare earth elements.
Right.
And then by looking at the different layers in the coral, we can reconstruct those Saharan dust events. So, and Gil was able to show that that does work. So next proposal is to get more money to do that rare earth element analysis.
Interesting.
Yeah. So yeah, we can do it with corals.
Yeah. So I was interested in you being able to pick up the Dust Bowl signature on that. Were you able to see anything such as the 1950s drought in New Mexico and Texas was almost more extreme than the Dust Bowl?
Right.
I don't know how, but I don't know how much dust, was generated by that event.
Right. So New Mexico and West Texas is interesting because there you're getting your winter precipitations coming from the Gulf of Mexico, whereas summer precipitations coming from the Pacific.
Correct.
So you got two different locations, and that winter precipitation tends to be more of that snowpack. So the signal gets really mixed up.
Sure.
So that 1950s, that would be an interesting interval to go in and look at closer to see. Yeah,
because the 1950s drought did so much damage across New Mexico, particularly, that you still see the impacts of all the 50s drought.
Right.
Across the region.
Right.
Yeah.
So I was just kind of jumping back to that slide to see if I can look at it real quick for you. So 1950s. Yeah, there is a little bit of an interval there where it's getting colder in the winters. So not almost the same extreme as the Dust Bowl interval, but yeah, that is one of those like 5-year intervals where the northern Gulf is colder in the winter.
Yeah, so it's all part of, because I know when I first started here, everybody talked about the fact that these drought intervals were every 30 years, right? And so you saw the 20s drought, the 50s drought, the 80s drought, and then we went into the 90s, and we just been having one large drought since then, with episodic events of rain. So I'm just curious how that shakes out. Yeah. So we have about a couple more minutes for some questions. If anybody else has any Q&A or questions they want to ask Dr. DeLong, because I have one more.
Okay.
So I guess here's my question. For somebody that is interested in doing graduate work on this, what would you give the students in terms of training, or because you come from mechanical engineering, then went to geographical oceanography? Is that the best way, or what? How would you approach this aspect of understanding climate?
So I would say, again, engineering for me was good because I had the math background for what I'm doing, but I also took a lot of biology courses before I actually went back to grad school. There was a 10-year interval between undergrad and grad school for me.
Well, yeah, because you were working with the USGS, or?
That was before.
Okay.
USGS was before I came to LSU. But yeah, in the interim, I actually worked a corporate job as a systems engineer. So doing color printers, and so very different.
Very different.
but I did go back and I was taking night classes, and I did take a lot of biology classes. I was about one class short of a marine biology BA or BS. So yeah, but I decided to go on to grad school instead. So I think a biology background is really important, but I think, what we do in paleoclimate, it's holistic. I do biology, I do geology, I do chemistry, I do physical oceanography, I do everything.
Right, sure.
So it's not just a specialty in one area,
Right.
And then we're getting into climate models, and yeah, we do a little bit of everything. So somebody who's got a strong chemistry background would be great at doing this work. Somebody who's got a good biology background would also be successful. Computer programmers, climatologists, yeah, I can train anybody.
Okay.
So if they're willing to do a lot of hard work in a lab, and we get to go to fun places. So like, hopefully we'll get to the Caymans this coming summer. We'll be going to Curacao in January. I'm going to help out a new professor at Texas Tech. He can't scuba dive, so I'm going to go to Curacao and collect his corals for him.
So who is that?
So it's Isaiah Bolden.
Oh yeah, I know Isaiah. Yeah, very good. Very good.
So it's a lot of fun, and it's just it's like having that drive to understand what's happening with climate change and putting it in the context of future climate change. What is natural climate variability?
Right.
It's like the AMO. It's this thing I've been trying to understand for years, because it leads to droughts. It leads to more hurricanes. Is it real? Is it not real? Yeah. And that last interglacial coral, there's a strong decadal variability in it.
Right.
Which is a really interesting result that
Well,
nobody's been really able to show. So
that's good. Well, folks, we have reached our 6 o'clock hour, and we want to thank everybody for participating. We also want to thank Kristine for joining us today and giving such an amazing aspect of how one looks at climate impacts in a very different perspective, what we would normally think of in terms of climate research, but important to understand how the biological and the climatological interact in ways that help drive this planet. So thank you all very much. If Randall and Kristine could stay on. So thank you all for joining us today, and we'll see you in December with Dr. Michael Langston talking about some aspects of stakeholders from the federal side of the work that we all do as part of understanding climate adaptation and change in this world. So thank you all, be safe, and get your boosters.
Right. Bye.